Okay, let's look at our proof on number 4 in your notes. We are given that ABCD is a parallelogram, so that statement and reason is already on there. We're adding segment DB. Remember, that's called an auxiliary line. It's just a line that helps you in your proof. And so DB, which is a diagonal because it's connecting two non-consecutive vertices, and our reason is simply that there exists exactly one line between 2 points. So our third statement, the reason for it is definition of a parallelogram. So let's go back up to number 1 in our notes and see what we know to be true based on the definition. The definition tells us we have 2 pairs of parallel sides, and those 2 pairs are the opposite sides. So we know the opposite sides of a parallelogram are parallel by definition. Remember, these things we do not know by definition. So we are going to put for our statement the opposite sides that are parallel. And so that is this reason right here, that segment AB, make sure you use the segment bars, is parallel to segment DC, and segment AD is parallel to segment BC. Remember, if you don't use the segment bars, you're talking about numbers, and it doesn't make sense to say numbers are parallel. So our fourth statement is using the fact that now we know we have parallel lines, we know the alternate interior angles must be congruent. Remember, alternate interior angles are ones that you can draw with a Z. And so I can make a Z with AB and DC being parallel, and that tells me that this angle is congruent to that angle. So that's angle ABD, which is congruent to angle BDC. I can also draw a Z with the other parallel sides, AD and BC. Now this is my Z that I'm drawing. And so now I'm saying these angles are congruent. So that is angle ADB, which is congruent to angle DBC. So let's mark those on here. We have this angle congruent to this one, and this one congruent to this one. The next thing that we're going to say is that DB is equal to itself. So this length of that diagonal would of course be equal to itself, and we know that that is by the reflexive property. So now we have enough information to say that these two triangles, triangle ABD and this triangle, triangle CDB, are congruent by ASA, angle side angle, angle side angle. Now remember what almost always follows proving triangles congruent in a proof. Remember CPCTC that says corresponding parts of congruent triangles are congruent. That's how we're going to prove everything true that we're trying to prove. So now I know side AB and DC are congruent because they are corresponding parts of those two congruent triangles, and AD and BC because they are corresponding parts of those congruent triangles, and these angles, angles BCD and DAB, because corresponding parts of congruent triangles are congruent. So both reasons, 7 and 8, are CPCTC. So just as a reminder, when you use these properties in a proof, the only one that you can say that you know by definition is that the opposite sides are parallel. These are all theorems that you would have to write out in words. So when you say that two segments that are opposite each other are congruent, you have to state opposite sides of a parallelogram are congruent. Okay, so these have to be stated in words. This one you can just say definition of a parallelogram. All right, good luck.